Hey guys, welcome to our lesson today. We're going to go over subatomic particles, which sound really cool, and I think they are pretty cool. You then identify the parts of an atom: the proton, the neutron, electron. Know the properties, the mass and location and charge of these, and determine the number of protons and neutrons and electrons in a neutral atom. All right, let's get started. So yeah, minimize this sucker up. Okay, so we're on page 7 of our notes. So make sure you find your way to page 7. And you'll see this. Now, where does this come from? Let me just switch cameras here and see how I can do this. I want to show you the periodic table. All right, and you'll see this is the periodic table. If you look in the little part, that was mine. The I could make it larger, but this is where we'll find a lot of the information that we're using today. Let me go get back started here. I guess I'll show myself today. Look back into what we're going to work on. First, defining the parts of the atom based on the electronic table. Okay, so let's start with the top right number right here. This 12.001 here, what does that mean? That is the atomic mass, okay? And what it represents is the average mass of all of the known isotopes. Of an element. All right. And then this number right here. Now, I should talk about this a little bit. We're going to learn more about isotopes later, but they're different versions of the same element. And because there are different versions, we just take the average of them. All right, let's move on to this next number. It's a large number down on the bottom left on the periodic table, and it represents the atomic number. And we often abbreviate it like this, atomic number, and it's the number of protons in every atom of this element. And like a fingerprint, this number never changes. So if you're saying, oh, an ion, well, I can't emphasize this enough. If you have an element of carbon, its atomic number is always 6. Then down here, we'll learn more about these, but I want you to understand where to find them. This is the electron configuration. And we talked about the Bohr model yesterday, and you notice that there were orbitals around there. So these are concentric circles around the center of an atom. And this tells you the number of electrons in each of those orbitals. So it's the number of electrons in each energy level. All you do is add the numbers to get the total number of electrons. All right, so how many electrons are in a neutral atom of carbon? 6, you just add those up. These different integers up here, notice they're negative and positive, represent the oxidation numbers. So oxidation numbers, what are that? Well, briefly, it's the possible ions that this atom can form. So the possible charges an atom of an element can have. All right, and then the bottom, this is the easiest one. The first one you'll see and notice, of course, is the element symbol. We're pointing to the C in this case. And it's the letter we use to signify the element. Now, it can be more than one letter. It's rarely 3 letters, but that's as many as you can use to identify an element. All right, so now we know all the different parts of how to read. Let's go into what they mean and how we can find them. So what do I mean by that? Well, we learned last time that an electron rotates around the nucleus that's very hard and very dense and very small compared to the orbital of an electron. Now, electrons can go and travel around this nucleus in different numbers for each energy level. So we have multiple energy levels around a core. That's the nucleus. Now, inside of the nucleus are the protons and the neutrons. And these orbitals are the electrons floating around in a cloud. All right, let's move on to this. We're going to first identify the different parts of the first one is the proton. So what is a proton? First of all, the first thing we discovered, it has a positive one charge. We first discovered it was a positive charge. And then we later said it has a mass. Now, how do we measure things? We don't call them pounds or ounces. We have a new measurement, and a proton is defined as one atomic mass unit. Now, I don't think I mentioned that anywhere, but AMU represents, I should always type it out here, equals atomic mass unit. Since I don't mind the pen for drawing, I just find it difficult to type with it. But the location of protons, like I said in this drawing, this is the proton, and the neutrons are found in this hard nucleus. I'll represent that with a different color. How about red? If I can write it over, yeah. Proton, the neutron on this dense center. I think I mentioned it's in the nucleus. That's where the nucleus is, and that is the symbol for a proton. Well, because it's, I'll talk about it later, they're closely related to hydrogen. We often use that symbol for a proton, but sometimes you'll see a lowercase p. Make sure you use lowercase. I don't know how to signify lowercase, but lowercase p as well. And how do you calculate it? You just look at the atomic number. You don't need to do anything more than that. Look at the atomic number and you'll see the number of protons. It's the easiest one because it's defined that way. The next one is the neutrons. Well, neutrons are neutral. Now that's important because protons and electrons both carry charge. And it's the reason why it's called a neutron. So we call its charge 0. How heavy it is? It's as heavy as a proton. It's 1 AMU, atomic mass units. And then where is it found? In the same place. It's actually closely connected to, that's in the nucleus. It's closely connected to the protons in the nucleus. And its symbol uses a lowercase n with a 1 and a 0. You'll notice these 1s and 0s represent something. I'll talk about that in a little bit. All right, how to calculate. You just take the mass number. That tells us the mass of all the protons and neutrons. And then you subtract the atomic number. You'll be able to equal the number of neutrons. All right. So mass number minus atomic. Why? Because this is protons plus neutrons. The atomic number is the number of protons. So if you subtract the p, you see how you're left with the n. That's all there is to it. Electrons are full of charge, but not full of mass. They have a very small mass of actually 1,836 of the mass of a proton or a neutron. So it's basically negligible. Where is it found? It's found outside the nucleus. It's the part of an atom that has lots of space. And that's why Rutherford's experiment was interesting for many reasons. But one big one is because nuclear, oh boy, I was messed up, is because it found out the atom had a lot of empty space in it. Electron, that's a fine thing, but you'll notice that there's a -1 here. All right. How do you find out how to calculate the number of electrons? Well, that always equals the number of protons, always equals the number of electrons, as long as it's a neutral atom. And a neutral atom. All right, let's use this knowledge, apply it to something new. Okay. Now, we had it all written on the previous page, and I think it's time for you to take that page and go ahead and fill these in from memory. But some of you might need help, which is totally fine. But try to do it from memory, pause the video, and write down as many as you can remember. And then if you're not sure, go ahead and unpause the video, and I will help you through it and check your answers. All right, go ahead and try those now. All right, thanks for doing that. Hopefully you paused the video and tried your best. Let's just go through what each of these definitions are. Let me just try to get it right on the line here. How do you get the number of protons? You just find the atomic number right from the periodic table. How do you find the number of neutrons? You take the mass number and you minus the atomic number of protons. And that always equals, okay? And how do you find the number of electrons? Well, the protons equal electrons in a neutral atom. How do you find the atomic number? Well, you can always look on the periodic table. It's the number below the element symbol on our periodic table. And sometimes we use pito for short. Or 2 is another option. It's the number of protons. Or the nuclear charge, we call it. Now, why do we call it nuclear charge? Because it's the only charged particle in the nucleus. I think that covers that. All right, what's the mass number? The mass number is the number of protons. Sorry, number of protons plus the number of neutrons. What's the nuclear charge? It's the number of protons. Or just the atomic number. I don't like that. All right. So in other words, trying to get it to be, yeah, I think we're fine there. All right. And that's it. Let's fill out this table based on these like 5, 6 principles. So I'll give you the first one. If we're looking at chlorine, let me just change my camera here to the oh, you know what I should do? I should pause for a second. All right, let me just show you the periodic table. Let's take a look at one of them. We're going to look at chlorine first. Try to get it where I can get them both matched up. All right, so we can see here. Chlorine is over here in the halogens. You'll see it has 17 protons. It's the atomic number. The number of neutrons, well, you take its mass number, which is 35 minus the number of protons, and that will equal 18. And then the number of electrons, you can simply say it's equal to the number of protons, so 17. Its atomic number, of course, is 17. Its mass number is going to be 35. You add the protons and the neutrons. And its nuclear charge is going to be 17, the number of protons, and its nuclear symbol is given right there. All right, let's go and do this for the next one together. We're going to do them all, so that works. All right, so we don't know anything about what this element is, but we know its number of protons. So I'm hoping you recognize protons is the number of the element number. So I'm looking for element number 15 on the periodic table. And so, you know what I should do is trying to get the periodic table on there too. You just go through, I wonder if I can just switch cameras, that might be easier. All right, so we look for element number 15 and we'll see it's right here. Phosphorus is element number 15. And so we can write in here, the symbol for that is 15. Let me just switch to that. Phosphorus. And then what's its mass? Well, you'll notice under phosphorus, it rounds it to 31. So we'll take its mass number around 31. Let's see. Yep, 31. And you'll notice that it's 30.97, but we rounded it. Right. We're off to now. If its mass number is 31, we know to add these two will be its total mass number, but what number of electrons? Well, electrons equal the number of protons in a neutral atom. So it has 15 electrons to match the number of protons. How about its atomic number? Well, its atomic number is the same thing as its number of protons, so it's 15. It's a pretty easy one. Its mass number is going to be how much mass it is, which means you take the number of protons plus the number of neutrons. So you got them right off this chart here. Let's get a little messy, so let me erase these two lines. But you multiply, you add that protons to the neutrons. I think you guess that it adds to 31. The nuclear charge is the number of protons, so it has a positive 15 nuclear charge. The nuclear symbol, we write it like this. We say phosphorus, we write its mass number, and then its atomic number. And that's all there is to it. All right, hope that works okay. Let's take a look at this one. We see it's carbon 14. Well, it's telling us that there's a mass number of 14. So this is the mass number. And so the number of all carbons have the same atomic number of protons. It's always 6. What's its neutrons? Well, they told us it's 14. 6 plus 8 is 14. Number of electrons is the same as its protons. The atomic number is the same as its number of protons. The mass number is adding those two together, which is 14. 6 plus 8. The nuclear charge is the number of protons. Notice it's sort of repetitive. Its nuclear symbol is just carbon. And then you write its mass number on top. And then its number of protons on the bottom. And that's it. All right. This one's a little harder. It just tells you the number of electrons. And it tells you its nuclear symbol. Now, its nuclear symbol tells you its mass number. So let's fill that in right away. Let's say its mass number is 16. It also tells you, of course, what element it is, the number of protons. And so we know it's element number 8. So it's the number of protons is 8. We know its atomic number is the same as its mass number and its proton. Oh, its atomic number is the same number as the number of protons. And its number of neutrons, well, we know now it's oxygen for sure. You might even know that it has a 16 mass number. So 8 plus what is equal to 16 is what our question is. But you could just, of course, subtract it or just do the math in your head. But the answer is 8. What's its nuclear charge? The number of protons, which is 8. You see how we figured that one out? All right, hopefully that helps. Let's keep trying these. I'll do the last one relatively quickly. This is argon. We know it's neutrons. The number of neutrons we're told is 22. So to find the number of protons, I take its mass number, which we know is 40, minus 22, we get 18. How about the number of electrons? Well, number of electrons equals the number of protons if there's no charge to it. Atomic number, same thing as its number of protons. Mass number, you add them up, which is 40. Nuclear charge, number of protons, which is 18. Atomic symbol, we rate AR. And then we rate its mass number on top and the number of protons on the bottom. All right, hopefully you get the hang of it. Try the next one on your own. Feel free to check my work. Calcium 20, 20 protons, 20 neutrons, 20 electrons, 20 nuclear charge. So easy, this one. It's calcium with 40-20. And I believe that's it. Open up quickly to the next page. Some good answers. These are ones I want you to try on your own, but I'll walk you through them as the answers go. All right. What is the one thing about you can always use to identify you because it never changes? Try that one. Well, what's something about you that never changes? Well, a lot of people will probably recognize that your fingerprints don't change. And I'd like you to write down something else that I didn't write. Yes, DNA is a good one. How about which numbers above is the one thing that can always be used to identify an element? All right. Atomic number, total number of electrons, and a neutron is to say of which number of protons. These are great for you to do. So I'll ask that you work this way and bring any questions you have. I can't think of anything that's tricky here. So you'll have to bring any questions you have to class. All right. Thank you. That concludes the notes. What's your homework? Well, your homework is note packet 7 to 9. We just finished that. And then the practice packet 4 through 7. You have a little more in the note packet to do on your own, filling those out. Make sure you have all those done for 100%. And then I'll see you in class. And hopefully you'll be working on your practice packet then. Thanks, guys. Have a great day.